Fellow students, welcome back to our video series, SmartPLS video series. Sorry, it's been a while. Actually, I got a bit busy. However, we are keeping on with our video series, and this is video number 15. In the prior videos, if you can go back, please, to the prior videos, we have discussed the structural model assessment, and we started with the step one, which is collinearity, checking for collinearity issues. Step two, checking for the relevance and significance of the structural model relationships. And in step three, we have addressed R squared, okay? And I've showed you in the video, in the relevant video, and this was video number 14, how we calculate R squared, the meaning of R squared, and the significance of R squared, etc. In this video, number 15, we are continuing with the structural model assessment in our video series. Specifically in this video, I am addressing actually the effect size, which is F squared. Okay, so I'm going first in this video to present what F squared is, what the various level of F squared could be. We might have weak, moderate, and strong F effect size, okay, which is the F squared. Okay, and we're going, of course, to use SmartPLS to showcase calculation and reporting of these calculations for F squared using our data on the factors affecting the online banking system use. So please stay tuned. All right, my fellow students, okay, so what is effect size? Okay, what is F squared? Okay, let us see. All right, so F squared actually would help you if you got a model, okay, the same one as we have been discussing, many factors affecting online banking use or online banking system use, okay? So we have many dependent variables or one dependent variables and many independent variables in our case. Okay, effect size will help you detect the variation between the impact of one dependent or one independent exogenous variable and the other one. So let's say in our case we have trust, we have perceived usefulness, and we have perceived ease of use. All right, in the effect size, we'll be able to know how much trust would impact the online banking system use and how much perceived usefulness will impact and how much that perceived ease of use will have an impact. And then the difference between the impact of this and the impact of that. So if one variable impacts or provides or contributes this much impact, the other one may contribute this much. However, the third may contribute only little or tiny bit, just this much. All right, so effect size will help you in SmartPLS understand the role or the weight that specific dependent or sorry, independent exogenous variable may play. All right. So as I defined that, we have a formula, and it is r squared included minus r squared excluded divided by 1 minus r squared included. We'll come to this formula in SmartPLS and apply the needed calculations. All right. All right, the change actually r square included and r square excluded represent the r squared values of the dependent latent variable when a selected independent variable is included or excluded. Okay, so we'll come to SmartPLS, we'll try to include some variables, exclude others, and then check the variation and check the changes in r squared. Okay, the change in r squared values is calculated through estimating the PLS path model 2 times actually. We simply, if we have trust, perceived usefulness, and perceived ease of use, we simply remove trust, check the r squared, then undo, okay, put it back, and then remove perceived usefulness, and then check r squared and see the impact, how much this has changed, okay, and the perceived ease of use, all right, and remove it and just undo and see the change. All right, so we check all the variables that are pointing to a specific independent or dependent variable in this case. All right. R square included reflects the effect of all independent variables or constructs in the model. Simply, now a student may ask here, or a researcher following us in this series may just inquire and say, okay, so I know just one R squared. How can I differentiate between excluded and included? It's actually R squared. It is the included ones. Okay, so which means like when I have all the variables listed in the model, I get simply R squared. However, R squared excluded happens when I start just excluding some variables one at a time to detect the differences in the variation or in their impact on the dependent variable. And this is actually reflects the F square. Okay. Let's move further here. We have a rule of thumb here. According to Cohen, you can see me maybe larger here. All right. Okay. According to Cohen, 1988, as a rule of thumb, we have a weak effect F squared. Okay. Of a weak effect when it falls below 0.15 but higher than 0.02. Okay, and it is actually moderate when it falls above 0.15 but below 0.35. All right. However, when it goes above 0.35, as the case right in here, then we have in this case a very strong effect or a strong effect as categorized. All right. Furthermore, okay, here I want to just, okay, here in this case, you'll understand just now in SmartPLS. All right, so the higher t values and higher standard beta would reflect on a higher F squared. Okay, let's now move to SmartPLS and then probably back to PowerPoint to continue with this video number 15. Okay, here in our SmartPLS software, we go into our model, which is the technology acceptance model. Okay, we are studying here. Let me just, okay. As you notice here, we are studying the impact of several factors here mainly. Perceived usefulness, perceived ease of use, trust, how they impact attitudes towards using online banking system in our case here, okay? So what we have to do here is that we have to calculate and find the effect size, all right? For the sake of saving time, I have prepared a list here, okay? Just a table here, some data for you. Okay, so what we have to do, as I explained for you, now if we go and calculate the PLS algorithms, all right, okay, and we go back to our model here, as you see in this spot here, we have, that's R squared, all right? That is R squared right here. Let me just annotate this, all right? The mouse, okay, let me annotate it with a touch, okay? That is R squared. I have an R squared of 0.198, all right, or 19.8%. Okay, here, what we have to do in order to detect the effect size, as I mentioned, the effect size, we find the variation between one variable and the other. Okay, and let's see here. All right, let me remove this torch. Okay, all right, and okay, okay, go back to the mouse. All right, here we have trust. Okay, we have perceived usefulness, and we have the perceived ease of use, all right? And all of them have arrows pointing to what? To the attitudes towards using the online banking system. All right, so this and this and this are giving us R squared of 0.198 or 19.8%, and this is R squared included, okay? All of them are included, okay? What we're gonna do here is, all right, so now we have here for trust, perceived usefulness, and the perceived ease of use, this is the R squared included, which is 0. As I see in 0.198, all right? So 0.198. Okay, so that's for all of them. Okay, this is R squared included, okay? 0.198. Okay, let's go back and get the R squared excluded in this case, okay? What we have to do is very simple. We take them one at a time, all right? So we take off trust, okay? We just remove trust, okay? And we run the calculation again, okay? So okay, we run the calculation again, go back to our model. It is 19.5. It's not 19.8 anymore, it is 19.5. All right, so we record here 0.195. Okay, and this is for trust, and then let us undo. Okay, undo. All right, everything is back to normal. All right, let's now remove this variable, which is the perceived usefulness. Okay, I removed this. Very simple. Go back to calculate PLS algorithms. Okay, and start the calculation. All right, go back to the model again. Okay, how much do I have here? 0.141. That's a big difference, actually. So perceived usefulness, I got here 0.141. 0.141. Okay, oh, there is actually a big difference in this case. Okay, so this is R squared excluded. As you notice that what this contributes to the variation, this variable, what this variable contributes to the variation is actually much different than what this variable contributes to the variation. Okay, let's go to the last one. First, we have to undo, get everything back to normal here. Okay, I undo, okay, and now what we have to do is we go back to removing this variable and rerunning the calculations, okay? PLS algorithms, okay, the result we will have is 0.146, okay? And let's undo, okay? So 0.146 in this case, okay? Here we got this, okay? 0.146, okay? So now we have these values, okay? 0.195, this is R squared excluded. Let us get the effect size. How do we get the effect size? Very simple. Go back to our PowerPoint presentation. We had in slide 1 the formula, which is R squared included minus R squared excluded divided by. So let me go back to the Excel sheet. So this is, let's put the formula in. So this one minus, all right, this one into parentheses, okay, into parentheses, okay, and divided by, all right, divided by 1 minus R squared included. So 1, again, open parentheses, okay, 1 minus R squared included, which is this one, all right? And then close parentheses, and this is the result, okay? So we simply drag this formula to get the result on all of them, okay? So we had some sort of a variation. It is more here on these two variables, more in comparison with trust as an independent variable. So simply where we go, when now we have the effect size, is it, let's go back to the rule of thumb that we have here spoken about. Weak, if it is below 0.15, it's weak, all right? And I see them all weak actually, okay? So the effect size in our model here is actually weak, all right? So now we have the results just in front of us here. What we do is we report them, okay? We simply take, all right, so trust, we have trust, okay, the effect size is this, copy, all right, and then go to this sheet, and this is trust, this is the Fsquare, put it here, all right? It just would not move it actually from one sheet to the other. All right, let me go back to this. I'll try to get all the table at once, copy, and simply paste it right in here. All right, here we go. And then the effect size, this copy, put it here, same issue. All right, so it is actually equals to this, all right, equals to this. All right, this is for the F square, for trust, perceived usefulness. Here we go. Perceived usefulness here, and the perceived ease of use, sorry about that, perceived ease of use is this, all right? Perceived ease of use is this one, all right? Here, if we look at our values here, look at that. You see, the lower the standard beta and the t-value, the lower is our F squared, the effect size, okay? The higher, as you noticed here, higher standard beta, sorry about that, and higher t-value yields a higher effect size or F square. All right, in this way, as I showed you, we have calculated the effect size in our model. Let us go back to the PowerPoint presentation. So it's a weak effect size, as I detected. Higher t-value and standard beta would reflect actually a higher F squared and vice versa. Okay, so the lower and the lower beta and the lower t value would result in a lower f squared. In this video number 15, my students, my fellow students and researchers, we have addressed f squared. In video number 16 coming soon, very soon, we are going to address the last step in the structural model assessment, which is the predictive relevance, or Q squared. Okay, so please stay tuned for coming videos, and always go back to our prior videos just to keep the chain ongoing, because this video series continues and builds up on prior videos. Kindly stay tuned. Bye bye for